Hello everyone, welcome to the video on Handshaking Theorem. Handshaking Theorem is a powerful tool for understanding the connection between vertices and edges in undirected graphs. Let's get started. Let's analyze the Handshaking Theorem using a university reception example. Imagine you are attending a university reception where students, faculty members and staff are all gathered. During the course of reception, each attendee shakes hands numerous times. So we want to know if it is possible for each person to shake a different number of hands. To model this, we use a graph theory. We model this problem with a graph G equals V, E, where V is people at the reunion. That is, V is vertices, which represents the people. Here we denote two people as U and V. Next, E equals U, V. E is edges, which represents the handshake between people. Edge U, V indicates the person U shakes the hands with person V. So we are representing two people U and V as vertices and their handshake as an edge. Now let's understand the theorem. Handshaking theorem is also known as handshaking lemma or degree sum formula. It states that in any graph, the sum of degrees of all vertices is equal to twice the number of edges. In this graph, we have two vertices U and V and one edge connecting them. The vertex degree or degree of vertex is a number of edges connected to a vertex. The degree of U is 1 since there is one edge connecting U and V. Similarly, the degree of V is also 1 because there is only one edge connecting V to U. So each vertex has a degree of 1 because there is only one edge connecting both of them. Next, sum of degree means we need to find the total degree of graph. That is, you add up the degrees of all vertices. And we know that degree of U is 1 and degree of V is 1. Therefore, sum of degrees equals 2. Next, twice the number of edges means each edge is counted twice when summing the degrees. If there is only one edge connecting U and V, the number of edges will be 1. In the handshaking theorem, the expression 2E refers to the twice the number of edges in the graph. The notation E denotes the number of edges in the graph. So 2E means you take the number of edges and multiply it by 2. Here we have only one edge. We multiply it by 2, so we get 2. According to the handshaking theorem, the sum of degrees of all vertices equals twice the number of edges. It can be mathematically represented as given here. Look at this expression. First, a graph is defined. Let G equals V, E be an undirected graph, where V is set of vertices and E is set of edges. Next, sum notation. The sigma symbol denotes a summation. Here it sums all degrees of vertices in a graph. The notation V belongs to capital V means we are considering each vertex in a set. Small v is vertex and capital V is set. So small v is one of the vertices in the set capital V. In other words, we are looking at every single vertex in a graph. Degree of D is degree of vertex V. It represents the number of edges that are connected to the vertex V. Look at the graph. It has three vertices A, B and C. The edge connecting these vertices are AB, BC and AC. Vertex A has edges to B and C, so its degree is 2. Vertex B has edges to A and C, so its degree is 2. Similarly, vertex C has edges to A and B, so its degree is 2. Summing up the degrees, we get 6. Therefore, the left side of the expression is the sum of degrees of all vertices in the graph. The equal sign indicates that the two sides of the equations are exactly equal. Now coming to right side of the equation, we have 2E, which represents twice the number of edges in a graph. Here E denotes the number of edges in the graph. Now count the number of edges in the graph. It has 3 edges, which are edge between A and B, edge between B and C, edge between A and C. So number of edges is 3. Substitute the value in the formula. So the expression 2E evaluates to 6 when E is 3. The sum of vertex degree is 6, which matches twice the number of edges, which is also 6. This confirms that the handshaking theorem holds true for this graph. Therefore, the handshaking theorem states that in any undirected graph, the sum of all vertex degree is equal to twice the number of edges. That's all for this session. Thank you so much.